So let's do a quick briefing of the solid principle from the last from yesterday. So solid is stand for single responsibility principle, open close principle, risk of substitution, in interface segregation, and dependency inversion. The single responsibility says that as you're building application, one class should do only one activity, or probably one class should cater to only one stakeholder. Like it is catering to only say the CFO, it is only catering to say an HR, or it is only catering to the IT support staff that we have. And then this support staff is uh, responsible for handling the call center, right? And then this call center is going to will be used by end customers. And then these customers, when they were transferring money, they saw a message on the screen that your transaction has failed, right? And then because the transaction failed, they wanted to call the IT support. Now, they all are some form of stakeholder. And when you're building an application, which is going to have classes for each of these implementation, uh, if you do it right, then your applications are going to be a lot easy for maintenance. And then it can only happen once you understand the single responsibility principle the right way. Uh, the open close is that if you write program against interfaces, right, depending on what implementation you give, your application will always be your application will be open for extensions. List of substitution lets you put one object in front of another object, and the parent class, if you're writing code with the reference of the parent class, you will be able to substitute this object with the other object. These two, they're more from the interface creation perspective, that one interface should have only one type of methods inside it, and the second interface is going to have something else, which are logically disconnected. The dependency inversion is writing code through dependency injection framework, and it is going to have you loosely coupled application where the object creation is handled differently. Once you understand this, you're going to notice that you will more or less be violating the single responsibility uh, multiple times in your application. One such example is having a car class. Now, a car is going to have at least two methods in it. One is drive and one is, say, stop or brake. Like the drive function is going to increase the speed member of this particular class. So speed is going to be set to 40, say, after you call the drive function. And after you hit the brake function, the speed is going to come back to 0. Right? So car class is fairly straightforward. It is going to have an integer member and it's going to have two operations on it, drive and brake. But while people were inventing car, something happened at the law level, right? And a car will there will be a driver who is going to drive this car, right? Driver is going to have a name and the driver is also going to have an age, right? These two things, they were kind of working fine. The driver had an object of car in it, and using this object, it was able to call the drive function and the brake function. Make sense? Until the law came in picture, and law said that the driver age should be greater than 18. Right? And that is just the law in our country. But then other countries, they're like a driver, if he wants to drive by himself, should be greater than 18. But then if he has a parent or a guardian, then under a guardian's provision, the driver's age can be 16 as well, right? So the law, depending on what state you are in, could be different. One says that you should be 18, one says that you should be 18 or you should have a guardian and a 16-year-old can drive the car too. All right. The question is, how do you connect the car and the driver and different laws that are coming in from different states, right? And for that, Let's jump back to Visual Studio. I'm going to add another project. I'm going to call it console application. I'm going to call it driver demo, or let's just call it decorator demo. Let's just do the wiring up code. If I hit control dot, Visual Studio will provision this code for me. And if I hit app dot run and hit control dot, it is going to provision the run function as well. So in the run function, I'm going to get rid of this constructor for now, and this as well. Let's go ahead and add a couple of classes. I'm going to add a class. So I typed the class short key here and hit the tab key twice, and then it got me a new class. So I want a car. A car can have a name in it. So let's just create a public property string and call it name. And a car is going to have, say, speed in it. Okay, then let's add a class for the driver as well. The driver is going to have a name, and it's also going to have an age. Right now, in the app class, I'm going to come here and I'm going to create the driver object assigned to new driver. And I don't have to pass parentheses. In the curly braces, I can set the name as Zia and age, say 20. And I'm going to create a car, new car, and the car name is, say, Honda. And the speed in the beginning is definitely 0. So not a semicolon inside. All right. Now I want to call the drive function. Right. So let's go ahead and add those two functions. So I'm going to add a public function drive. And then drive function simply is going to say speed is 40. I'm not going to worry about setting this member here. And then I'm going to add another public function. I'm going to call it break. And this break function is going to set the speed back to 0. Now a car, for working fine, it will require a driver. So the driver that we want, we're going to have to save it inside. And I'm going to set it this way, driver. And the driver kind of sits here. Let's go ahead and change this as well. I'm going to put a $sign here, and I'm going to say driver dot name of age, driver dot age is driving at the speed of 40. I'm going to copy this. Has stopped the car, and the speed is 0. Right, with me so far? So I have a car class, I have a driver class. The driver is a member of the car class, and I want to give it the ability of drive and the ability of brake. So these two functions are going to get called. Let's go ahead and run this program, and the car will require driver. So I'm just going to give my name here like so. Now if I hit Control F5, and before that, if I change the startup project to Decorator demo, I can Control F5 now. And Zia of age 20 is driving car at the speed of 40, and Zia has stopped. So those two functions, they're kind of coming in picture. They're kind of taking form until the law came in picture and said that hey, driver age should be more than 18. Now, if you are a regular programmer, what you're going to do is you're going to come here and you're going to say driver dot age must be greater than 18, and only then you print this output, right? This is how regular people write program. I'm not going to put a semicolon there, sorry. Right, so because the age I entered is 20, this thing is going to get through fine. I'll be allowed to drive. Make sense? But if I drop the age to even to 18, it won't work. But then let's set it to 16 first. Okay, and then it is saying that I am not allowed to drive, and it has stopped me. A better way to stop execution is that you simply throw an exception. Throw a new exception. And then I'm going to repeat this part. Double quote like so. Throw new exception. And this. Okay, so I'm going to say that the driver dot name of age this is underaged, right? And because of this, if this throw exception, the application is not going to proceed because the age is still 16. Age is let's put a breakpoint and see what happened. I was expecting an exception. So in the drive function, it came and the age here is 16. 16 is greater than 18. This condition should have failed. Am I doing something wrong? 16 is greater than 18. What is happening? So there's something called as immediate window. In the immediate window, you can use the objects in the current syntax. I don't know, should I reverse the condition? I don't know. I'm just going to stop this, hit F5 again, and 16 is less than 18. This is true this time, the condition was wrong. So it's going to throw an exception, and Zia of age16 is underaged. I'm going to hit F5, and we're going to see the same exception. We're going to see the same exception message on the screen as well. Zia of age16 is underaged, right? So the rest of the flow did not continue. But both the approaches, they are wrong, right? You should not have, your application should avoid throwing exception in the first place. The second is, this is kind of violation of the single responsibility principle, right? The single responsibility says that one class should do only one activity. So a car should only give you ability of driving, right? This is state law. So this does not belong here. This function is doing two activities, drive and have state laws and enforce state laws, right? So everything that you are doing in the function, you should put it in the function name. And the moment you start seeing the and keyword, you are violating single responsibility, right? We saw that it is because of age law from the state, we are not able to drive our car. So this part we have to remove. We can't do our validation over here. And to do that, we'll have to figure out another class which is going to enforce these state laws. And this is where the inheritance part of object-oriented programming, it becomes very interesting. So what we're going to do is we are going to take the abstract implementation of this car and we're going to paste it in a new car. I'm going to come here and create a new car. And I'm going to call it Honda, and I'm going to inherit it from the car class. Now we know that car is an abstract noun, so I'm just going to put the abstract keyword over here And in front of all these functions, I'm also going to put the abstract keyword. And I'm going to get rid of all of this. So this goes. And I'm going to take away the break functionality as well. And put an abstract keyword over here. So this is step number one, that we do some refactoring and we extract out an abstract class from this. So now it is mandatory for the Honda class to implement these functions. And to implement those, we'll have to put the override keyword over here. So with override, we are explicitly informing the CLR, the C# compiler, that this is intentional. The parent implementation, we are going to take that away and we're going to replace it with our custom implementation. So Honda should only care about driving and it should not care about the state law. But let's go ahead and get this one to working. So I'm going to replace the car instance with Honda like so. And I'm going to replace car with Honda as well. If I control F5, it is still complaining because we have that condition there. So let's go ahead and get rid of the condition from this class. Now we want to figure out a way of calling this drive function from the outside. We would probably want to put this condition over here. If zr.age is less than 16, less than 18, then you throw exception. Throw new exception. I'm going to leave it empty this time, right? Otherwise, it is just going to call this function, right? But then once again, this is violation of the single responsibility principle. Now this function is run and make sure laws are enforced, right? We don't want that. So we cannot put in the run function. So Honda is honoring the single responsibility principle, but the law is kind of falling apart. So we'll have to add the law class here and we are going to inherit it. It's going to look very unusual, but then we are going to inherit it from the car class. And the word inherit is right here because car is an abstract class. Now I'm going to hit control dot and implement these two methods. All right. And in this law, I'm going to do something very tricky. I'm going to create another car object and I'm going to call it underscore car. And over here, I'm going to accept the car object like so. And I'm going to say underscore car is assigned to car. We have done this like multiple times. The only trick this time is that the law itself is inheriting from car and we are saving a copy of the car inside, right? And over here, I'm simply going to say underscore car dot break and underscore car dot drive. What I've essentially done, a class like this, which takes the object of the same parent class and calls a function without any condition, is called a pass-through class. So I'm going to put a comment. I'm going to call it a pass-through class. So the object is going to come inside the constructor. It is going to get saved and you can call the functions without any condition. It is just going to pass through. And we're going to change the implementation of the parent class. Now we are not going to create just the law. We're going to say just the car. We are also going to create object of the state law. And then to this law, we're going to pass Honda like so. Okay, and now we are not going to call the object of drive from Honda. We're going to call it from the state law object. Right now, if I hit Control F5, nothing is going to change, right? Because there is no condition. There's no if block that is checking for my age and everything is getting through. Because of the state law, I'm going to come to the state law function and I want to have a restriction on the driving, right? I don't have the driver object. So let's go ahead and add the driver object as well. So I'm going to say underscore driver. And in the constructor, I'm going to initialize the driver as well. So underscore driver assigned to the driver parameter. And then now that I have the driver object with me. I'm going to say driver.age less than 16. This function is going to throw an exception. Age law. And if everything goes through fine, it is just going to call this function. Now I'll have to pass two parameters at the car itself and the driver, and the law is going to take care of the rest of the things. Right over here, I'm going to take away the driver ability from the car itself, and to the car constructor, I'm going to pass the driver object. I can make it private as well this time and say underscore driver assigned to driver, and to these functions, it is just the name that we would want to use even for this. All right. So now it is the state law that is going to enforce that the age law is met before something else happens. Okay, so let's go ahead and run this program. So Honda is kind of completing because it takes a driver object. Now I don't have this flexibility. I'll have to I'll have to keep those names in the driver class. So let me go ahead and delete this constructor. All right, let's go ahead and debug this program. I'm gonna hit F9, hit F5. All right, the first three statements, they're going to create the required object for this. So the driver is created, the car itself is created, and now if I hit F11, I'll be taken to the constructor of the law class. The law has received the Honda, and the driver is myself, right? So it saves those two things as a copy inside it. And I'm going to put another breakpoint in the drive function. Now, if I hit F10, it is going to go back to the run function. In the run function, the state law object is created. So if you look at explode this, you're going to see that it has a car, which is Honda, and it has a driver, which is Zia. Right now, if I hit F11, I'll be taken to the drive function, but then it is coming from the law class, right? In the law class, I'm going to validate the condition first. If the driver age is less than 16, and this is false, I guess. 16 is not less than 16. So it's going to let it slip through. I should have changed it to 18, but if I hit F5 now, okay, my object creation is kind of messed up. So driver each console.writeLine. Okay, so I don't know where driver is coming from. Okay, got it. Sorry about that. When I move things around, something broke. So I'm going to stop this. The car class still has access to driver, which I can live with. Just that I should have changed driver to underscore driver over here. And now I don't have underscore driver. I can set it this way and everything should work fine. And now that we are at it, let's change the condition back to 18. If I hit F5 now, hit F5 again, we are in the law class drive function, and this drive function is going to validate the government law. It's going to say that age law is violated, so it's simply going to throw an exception. And in that exception, we're going to see that the age law is violated. So the application won't continue. What we have essentially done, there is a keyboard shortcut called Control M, Control L. Let me do that. And for some reason, it doesn't work on my laptop sometimes. All right. So when you hit Control M, Control L, all the code is going to kind of collapse. Now, if you hit the plus sign, it is going to open up and only show you the insides of it. We have an app function with a run function inside it, which we are calling from the main function. We have an abstract class car, which is having all the car essential information. It knows the driver, it knows the car parameters, the speed at which it's driving, and it gives you two functionalities: drive and run, drive and brake. Honda is a specific implementation of this car, and it provides you the actual implementations. So the speed sets here, and then it prints things on screen. Then we have a driver. A driver has a name and age, and there's a law. Law enforces that the driver who is trying to drive the car, he should follow some rules. The law is, because it is enforcing car, we are going to create a new class which is going to wrap the actual car implementation inside it, and to wrap another class inside another object, you can define member of the same type and wrap it using the constructor, right? And then this constructor, if we pass it the object of Honda, Honda is going to get wrapped by the law. So the law kind of sits outside, and because these are abstract function, law will have to provide implementation for all of these. Through these implementations, through these modification, we get the driver object and we apply the law here, and we do raw related things here. Once the law is taken care of, once everything is correct, we say that now the driver can drive the car, and that's when we call the car.drive function. Right? And it is through this drive function that the actual driving happens. Right? Now we are a lot aware of the composition hierarchy. But then once again, if we use the Microsoft dependency injection framework the right way, we won't know which car object we have. We're going to call it, I'm still going to keep calling it Honda. I'm going to call this car, right? If we take this thing away and make it part of the dependency injection framework, we won't know which object we are getting. I'm pretty sure that all of you have done some form of logging. So when you come inside a function, you are used to writing this kind of code. Log : drive, inside drive function, right? Things like this. A lot of you must have written code like logger.log, and then this log is going to become the go-to log for you. That log : drive logging. Then probably you would want to put the time as well on at which time you are coming inside the function. So it is the time.now, right? Writing code like this, it should not become part of your actual business logic. Your actual business logic should do only the business related work. This function is only supposed to set speed to 40, right? That's all you should be doing here. All the logging, all the exception handling, all the validation, all the laws that you want to implement around that class, it should sit in a different class. Now, if I want to have logging implementation, I'm going to do that real quick. I'm going to copy this. I'm going to create a new class, and I'm going to call it logger, right? And logger is going to take the same object. It is going to assign it to some other object inside it, and the rest of the code is going to look like this. I'm going to call it logging. Okay, let's just type the time here. It's going to become date time.now. I'm going to copy this, and I'm going to copy datetime.now once again over here, and I'm going to remove this condition, right? Because validation is not part of the logger implementation. Validation is part of the law class, and actual driving of the car, setting the speed to 40 and say 0 again, is a responsibility of the car, right? What we have done is we have identified what is common between those three entities, and that's a car. And because it is common, we are going to go about creating the objects. So I'm just going to call this law again. And instead of this, I'm going to call it logger. And to logger, I'm going to pass the law object. Right now, if I say car.drive, it is going to call the drive function of the logger. The drive function of logger is just going to print out the time. It's going to call the drive function of whatever object is getting passed to the logger constructor. And that object that we are passing is the law object. So it's going to invoke this function here is going to invoke the law.drive function, and then this law.drive function, if the condition matches, is going to invoke the drive function of the actual car. So it's going to come over here. So let's go ahead, and to see a happy path, we are going to increase the age back to 20, more than 18, and I'm going to hit F5. Let's see it in action actually. So if I hit F10, it is going to create the driver object, Zia. It's going to create the car object, Honda, with these details. It's going to create the law object with the car tucked inside the law, and it's going to create a logger object with the law object tucked inside the logger itself. If I hit F11 now, notice that we are in the drive function of the logger, right? It is going to log it on the screen, and we're going to see this. If I hit F11 now, it is going to go inside the drive function of the law, right? And it's going to validate that the laws are being met, right? 20 is greater than 18. So this is false. It is not going to go inside. So the driver can drive. Then if I hit F11 one more time, it is going to go inside the drive function of the car class, right? And now it has set speed to 40. It's printed a friendly message on the screen, right? Z of age 20 is driving car at the speed of 40. If I come out now, it is going to return. It is going to kind of unroll. It has come back to law drive function. The law drive function ends, and then it came back to the drive function, and then the logger function. And the logger is going to once again print this thing on the screen that we started driving at 10:05:09, and then we stopped driving at 10:05:59 a.m. Right? So if I hit F10, it calls the brake function, and the brake function is going to go through the same cycle. It is inside the logger. The logger is not logging anything about braking. There is no law around who can stop the car. Anybody can stop the car. So it just falls through, and then it actually says the speed to 0. It prints a friendly message. We don't have to do this console.write line here, but then it comes out and the program kind of ends. Right? Has stopped the car and the program has completed. So this comes out, and it comes out from the run function inside main, and the program kind of terminates. Right? So these three statements, the logging statement is part of the logger class, the law statement is part of the law class, and the actual driving part is happening inside the car class, the Honda class. So each class is honoring the single responsibility principle, right? If you're doing, where were we? If you're doing logging as part of the Honda class, that hey, logger.log inside the drive function, then you are violating single responsibility principle. And the best way to do that is figure out what name you are using for the class. If you want to do logger.log statement inside such functions, all you have to do is just change the name. You say that, hey, I'm going to drive as well, I'm going to do log as well. And every time you see add, that is a violation of single responsibility. So that is going to be your biggest clue, biggest hint that your program is violating one of the solid principles. All right, so with that, let's just stop our session for today. And if you guys have any question, you can ask me now.